All right, everyone, how we doing? Doing good. So, how's the what do you call it? The lectures going? How you guys doing? Doing good. Is Dr. Morris treating you pretty nicely? How are the homeworks? The written homework, is that what it is? Right? It's shortened. Okay, so not. Oh, in the beginning, it's a lot. Yeah, because there's like the proofs and what is a linear time invariant system, correct? What is a memoryless system? What's a system that's a causal system, right? Does that make sense with everybody? So then, what are you guys talking about in the, let's see, is this the right one? Introduction, signals and system properties, linear time invariant systems. DT is discrete time, right? Discrete time systems, discrete time convolution, continuous time convolution, linear time invariant differential equations, right? And linear time invariant difference equations, right? You guys understand the difference between differential and difference? Differential is you have derivative, correct? And then difference, you have the n minus 1 or the delays, correct? Is that good with everybody? And then here's the videos, here's the homeworks, there's that. You had a homework due yesterday, right, for Dr. Morris's class. And then OW is the Oppenheim, right? How's that book?
It's fine.
It's a pretty chill book, right? Not too bad.
Shams is pretty good.
Yeah, Shams is pretty good. Is he making you do Shams too?
He mentions it occasionally.
Okay.
Sometimes he mentions like where they have their difference, like in terms of notation.
Okay, sounds good. So the basic problem with answers, not too bad. And then he posts the answers, right? He hasn't posted them here. Let's check. Did he run it? No, he didn't run it. He'll post it to you soon. And then homework 3, correct. What was this one? He doesn't post anything there. Okay, it's just a textbook. Solutions, you guys are going over the solutions, right? What do you call it? Solution for this kind of system, correct? All right, sounds good? Anyways, I'm not going to bore everyone with this. We're going to get into the MATLAB. Is that good with everybody? Did you guys look into computer assignment 4 already? Started it? Looked at it? Was what I mentioned helpful last time a little bit? Fourier series, right? And then there was that cool little video I showed you. It wasn't Mozart. That was Fourier himself that they were drawing. This, I'll pull it out another day. Actually, let me see. I got to show everyone this one too. EE360 pages, right? View all pages. EE360 content, right? Is that cool with everybody right here? Then I click on this video. Okay, I hope it doesn't make comp 3. There we go, comp 3. And then this little video I posted for you guys, really nice, right? Who watched it? No one? Oh, you watched it? How was it? Pretty fun? It's a good video, okay? There we go. Where you can literally, from the what do you call it? The first frequency, the fundamental frequency, right? Like the sine of 1 hertz, right? I'm just saying 1 hertz frequency. If you double it, 1 hertz, 2 hertz, 4 hertz, or actually, you're not doubling the frequency, you're just multiplying the fundamentals. So 1 hertz, 2 hertz, 3 hertz, up to however many hertz signals you need. Does that make sense? Was that a really nice little video? Good. Okay, so there's that. Let's get into the MATLABs because that's what I want to go over. MATLAB. That's MOBA. MATLAB. Anyone use MOBA Exterm in this class? Yep, that's how you get into the servers, for some of our software that we use. Let's see, lecture 4. Did I do anything there? Yeah, we did LTI systems. How was that assignment? Was that good? And then, Joanna, you graded all the assignments, right, for computer assignment 3? Not yet? You're getting to it? Not that bad of an assignment, right? You guys saw the filtering, right? You saw when you added two signals, a slow signal plus a fast signal, you see how it filters. And let me just mute this. There we go. Anyways, not too bad, right? And then did you understand what I talked about with the delays? I think Dr. Morris uses like an offset or something. He calls it some weird variable. I call it delay because it makes sense. Like, oh, if you have a signal that starts like n minus 3, right? N is equal to minus 3. So that's or 3 delays, right? 3 memory cells, right? So that's why I called it delay. And then I think he did something funny with this where you put the delay in there. There's many ways of implementing an LTI system. There's no one solution. There's many solutions to get to the same problem. It's like when people do what's 1 plus 1, right? They do 1 plus 1 minus 3 or something. There's many ways of solving it. So anyways, let's talk about your next assignment. For those who've started or haven't, let's see, EE 360D, lecture 5. Let's see, by David, I think. So let's do first part, which is Fourier. Let me just look at the assignment. Did everyone understand the assignment? Let's look at it. I'm losing my voice, by the way. Anyways, low pass filtering, right? What does a low pass filter do? Trivial question. Passes low frequency signals, right? So it's a high pass filter. Only passes high frequencies, right? You guys took the labs and saw filters and built like RC or CR circuits, right? Resistor, capacitor, or capacitor, resistor, right? V in, V out, and analyze the two, right? There's a way to do it digitally, and you guys got to see an example of it. And this right here is a moving average filter. They use this filter a lot in like stocks or when you're looking at like numbers just coming in at a time. It just tries to soften everything out. So the bigger your M value right here, right? The more data you feed it, right? Does more averaging over a long period of however long this signal is. He gave you H of N, correct? Exercise 1, visualize the filter. Everyone had a good time plotting this? Let's plot it for those who haven't done it yet. Fourier visualization. There we go. What do you call it? Let's draw a filter. Okay. So let's go from omega, right? Omega is our angular frequency, right? Equal to 2 pi f, right? So I'm going to do something fun. You see, from minus pi to pi, okay? So let's do minus pi, right? Is that good with everybody? To pi. Everyone happy with that? Question mark? Let's run this. I want to run this, okay? Control Enter. Let me see how many points it popped up. What did it say? 1 by 7, okay? Not too bad, right? But let's deal with this thing. So we want to generate more points, right? We don't want to have like a, what do you call it? A weird looking signal. Because if I were to do the following, let's see. H, right? We need to visualize this, correct? So how do you do this? Just visualize, or just literally type this in right here. So let's do m minus 4. Does anyone bother if I do this? Boom. Shared screen. Let's do m is equal to 4, right? Everyone did this? Let me do this. Let's see if anyone bothered by this. H top is sine omega, right? And then another parentheses right there. M plus 1/2. Is that good with everybody? Right? Not too bad? There's many ways of doing this too, okay? What am I going to do now? h bottom, right? The bottom numerator, sine w, or omega, over 2. Is that cool? So what's h? H top divided by, oh, I'm going to do this. Dot divide, okay? H bottom. Is that cool with everybody? So you could have done it a different way where you just, instead of doing like this, you can just combine the two, okay? It's okay. It just depends on how you want to treat your MATLAB, all right? Figure, name, I'm going to call it my low pass filter, exclamation mark. What do you call it? Stem, omega, or W, and H. And then let's do X label, angular frequency. Let's do this, $sign, backslash, omega, $sign. Okay, I'm just doing this because I like to see it. Interpreter, and then latex. Is that good, everybody? Okay, let me zoom out of this. It's a little too small for me. Y label, I'm going to call this one H of e to, okay. Yeah, e to the j omega. Is that good? Boom. Let's run it. Uh-oh, what happened? H top. Array indices must be greater than, okay. Let's see. Oh. It's thinking that this is a vector. So what I forgot to do is dot times, okay? And then dot divide there, okay. So this is its own value. It was thinking it was like omega of, it was treating it as a function, so whoops there, okay? Sounds good? Let's run it. Control Enter. Does that look cool? Not too bad, right? Does it look like a filter? I think he said to use plot, right? Plot. I don't think he said plot, but I'm going to tell you to use plot because I'm about to show you something a little funny. Plot. How does that look? A little weird, right? Not too bad. So now let's play with this right here, okay? We want it to look a little more detailed. So let's think about the most basic steps. Minus pi, right? 0, pi. What's the increment? Pi, right? So I'm going to do something funny. Okay? From minus pi to pi in increments of pi, right? Increment. I'm going to do increment right here. Inc is equal to pi. Is that cool with everybody? Watch this. Control Enter. It didn't do anything for me there. I wonder if it didn't like that. Whoa. For minus pi, let me see, what did it do? This should have worked, pi. Anyways, that's upsetting. Whatever. What I was trying to do is pi over 2, right? I'm trying to do minus pi over 2, 0, pi over 2, right? You're seeing the pattern, right? I'm trying to include the 0 value. That's going to be important when I do the following. Why is it not doing what I want it to do? Oh, let's do pi over 10. Is that cool? You guys like that? Let me do something fun. Pi over 100, right? Looks a lot more. What is that looking like? A sinc function. S-I-N-C, sinc function. But there's a problem. It's not valualizing that point right there, right? How do I force that point? So let me just talk to you guys because I don't think you're necessarily going to see this, but if you do, let me just write this on the side. Okay, you're going to have to take my word for this one. Let me see. I'm going to write this down, okay? Oh, there it is. There's my screen. H omega is equal to sine omega m plus 1/2, right? Over sine omega over 2. Is that cool with everybody? Okay. There's a rule that you have to follow a little bit. Remember this rule? It was, what do they call it? The sinc function. I think it was sinc of x, right, is equal to sine of x over x, right? Does that make sense? Right? That's the proof. So I want to turn these into sinc functions, okay? So, don't worry, I'll give you guys MATLAB code at the end too. We want to turn this sine into a sinc, right? So you see this term in here, right? I'm going to dot it like this, right? I need this term down here, right? So what am I going to do? I'm going to multiply by 1. Right? Multiply by 1. Going to use a pink marker. How about this term? Multiply by 1, right? Omega over 2. Omega over 2. Is that cool with everybody? Now, let's group things. So if I were to group this, like this right here, right? Right? If I grouped, yeah, let's with the green marker. Like that, right? Cool? Wait. It's supposed to be this guy right here. I don't like it when it's not too pretty. Does that make sense right there? I'm grabbing these two terms and these two terms right there to create a sinc. S-I-N-C. There we go. So now, H omega, right, is equal to sinc of omega m plus 1/2, right, over sinc of omega over 2, right? What are our leftover terms? This term right here, right? And this term right here, yeah? Omega m plus 1/2 omega over 2. When this value in here is 0, right? When omega is 0, right? Sinc of 0 is 1, right? Are you seeing what's going on? So if I were to evaluate, what do you call it? Omega at 0, right? These turn into 1s. And then, well, let me just show you this. I don't want to blow this one up. This one goes away, right? This one goes away, right? What are we left over with? Right? Is that cool? But then m is equal to 4, right? So once I plug in chug m, right? What does that give us finally? So that's 4.5, right? 4.5 times 2. Is that cool? Let's prove it. And I think I used a trick of his, which was really, really cool, where, remember this one? It was like the, what do you call it? I'm going to do it as, let me see, not find, I'm thinking of a, what do you call it, condition. Find my 0, okay? When omega, right, is equal to 0, right? Remember this trick? So I'm going to find my 0 in this guy right here, right? Once I find that, I'm going to do omega, right, of find my 0, right? There you go. Is equal to 9. You think this is going to work? Oh, what the heck happened? That's not what I wanted to happen. Find my 0 is equal to 9. Let's see. This should have worked. So omega equal to 9. Where's my find my 0? Okay, that works right there. Omega. There we go. Find my 0. We're going to set that one equal to 9. Let's see, because if I put this into here, I should get this. There, that's my 9. Let me see. Something's. Oh. No. Okay, wait. Oh, there we go. Okay, Control Z. I'm not trying to force the value in omega. I'm trying to force the value in H omega. You see what I'm doing? Sorry, y'all. I'm a little under the weather. H of find my 0, right? Does that make more sense, right? Omega is equal to 0, right? Here's my 0, right? 9. Ready? Control Enter. Looks good, right? What's the top value right here? Let me click on it. Close to 9. Are you seeing how this is pretty cool? But I don't think he's not talking about Fourier transforms, correct? Fourier series too deeply in the lectures?
Oh, I just did a little intro.
Okay, just a little bit. Okay, I don't want you going too hard on this, but this is how you do it. Okay? That's how you find the magnitude at that point. Okay, now everyone can do example 1, exercise 1. Okay. Exercise 2. Let's see. Using convolution, overlay this and H. So there's 2 ways of doing this. You can either do a brute force thing. He gives you the answer right here, okay? So there's 2 ways of doing it. You can either just force 1 divided by 5, right? 5 times, correct? Or you can do it the other cool way. Let me see. I think I have, let me see if I have it here. Do I have it? I want to make sure I see C4A. Yeah, there you go. See, I'm going through this stuff. Ooh, let me copy this. There we go. I like this. There we go. Yeah, you like that? I'll give you that to you guys. Cool? Everyone understands what's going on? So what did I do over here? Let's see. M is 4, and X. Okay, I was dealing with this for a while. So there's 2 ways of approaching this problem. You can just brute force the M's, and that's okay. You can do it like this. Let me show you. H is equal to 1, what do you call it? 0.2, 0.2, 0.2, 0.2, 0.2, right? Right? That's fine right there, okay? Or knowing that M is equal to 4, right? And that's where I was developing this right here, okay? And I did something fun right here because I knew I had a delay, okay? I have 4 points that are coming in, or 5. So let me just, I'll just copy this right here, right there. Boom. Is that cool right there? 1 divided by M plus 1, right? So if M is equal to 4, right? That's 1 over 5, right? That's 0.2, right? But we need to do that 5 times, correct? That's where this function comes to play, the ones. Everyone understanding what's going on? When does the impulse response start? At what time does it start? At 0, right? And goes down to M, right? Which is 4. From 0 to 4 for your impulse response, your averaging filter. Cool? So that's what I did right there. And then what about nx, or the time of x? I just went from -4 because we're going to do convolution, okay? So let me see what else I did. Oh, that's the other assignment we did. I know what happened here. So your assignment, and I was going crazy over this too, because I wanted to prove by hand, but I don't think he's making you prove by hand, correct? Because it would be painful. I'm wondering if he's making you do it. So at the first point, right, n is equal to 0, right? Cosine is going to be 1, right? But what's the average value of 1 plus another 5 points, right? So 1 divided by 5, right? 0.2, right? Right? So that's what I was wanting to see, because that's what my engineering brain tells me. So I put a U of n. I don't know if, Joanna, if we're going to deduct, I don't know. I don't want to deduct points because personally, I want to see numbers. Does that make sense for everybody? That the first point, cosine is 1, right? Cosine of n is equal to 0 is 1, right? But the last 4 points were 0, right? For my averaging filter. So that's 1 plus 0 plus 0 plus 0 plus 0, right? That's 5 points, all divided by 5, right? So 0.2 should be my first point. So I put a unit step. That's what made me happy right there, right? And here's my signal. Is that cool? So then what's my next part? Let me just copy paste this right here. Enter, enter, enter. And let me see, convolution. So I had to figure this out because the times matter, and convolution will give you the answer. But will it give you the time? No. So that's where you need to start figuring this out. So can everyone understand this part right here? My time for y and y is going to equal to my first time for x. That's -4, right? Right? Plus the first time for h, 0, right? Because x starts, for me, I started x at -4 to 50, right? So I add those two. You see how I'm doing this? I'm giving this to you guys. So this is your little treat for today, okay? Sounds good? And I'm doing a full convolution because that's what I'd like to see, right? Full convolution. What did I do over here? Because I was doing some other funny things here, but I think this makes sense. So hear me out, engineer. We're going from 0 to, I don't know, 50 points, correct? Or what did he ask for? 50, no, he didn't ask for 50 points. Yeah, that's weird. Yeah, he doesn't tell you how many points to do, but in the end, he tells you to do 100 samples? Yeah, 100 samples, right? You seeing what's going on? So I'm comparing my output and input, okay? I only want those two signals. So what I did here is I'm looking for the length of the actual signal, my input, right? So I'm going from, here's my output, right? Here's my full convolution, okay? Let me just show you what's going on. If I were to run, let me see, run this, figure 2, stem y0, right? Let me run that. You see that? What's going on? Right? Is that what everyone was getting? Cool? Yes? Who didn't start the assignment? It's okay. It's okay. Don't worry. I know. It's okay. What's that first point? Point 2, right? Are you seeing the philosophy that I'm like approaching this problem? I like to see things like work. So that's why I was doing these 4 points here, because that's what makes sense to me, okay? This point right here, right, should be 0. N is equal to 0, right? So that's where this time comes to play. So I was playing around with, what's his name? This right here, right? But let me punch this in and see let's see what happens. Oh, it worked. No, it didn't work. Because this should, oh wait. Sorry, I'm having a moment. You see x is equal to 0, right? Are you seeing that? Y is equal to 0.2. Ah, good. So then let me just check one thing. Here's ny. Ny is 0 to 59. But then I do this thing. Let me see what I did here. Y0 fit is equal to Y0 1 to length of nx, right? Let me check this guy out. Okay. Y0 fit, 55 points. Okay. The reason why I told you guys this is because Dr. Morris is saying to plot, what do you call it? Generate 3 plots in a row using subplot. Insert a legend. And you have to plot x over y. That's why I chucked it down. Okay? So if you do this, okay, right? ny, right? The time of y, right? If you put these two together, you'll be fine. Cool? But I want to plot x now. So let's do this. That's my output, right? Hold on stem and x, right? Y or x0, right? Do you think this is going to work? Hold off. Let's see if this works. I actually haven't tested this one. I guess it did work. Okay. Okay, so it worked. But do you see the problem right here? There's these 4 points right there, right? Of our output, right? There's no orange signal, right? Right? My orange signal is, okay, this is why I need to have labels. Labels, x, oh wait, my first point was y of n, and then x of n. Uh-oh, what happened? Undefined label. Oh, label. There we go. What? No. Legend. There we go. I'm having a day, y'all. Does that make sense? Our input x of n, right? It's missing here. Or is it because I have extra y, my extra output? So that's why I was cutting off these guys, right? Because look, if I clicked here, right, that's x equals 50, right? Right? And what about this one? X is equal to minus 4, right? This right here, my nx, right? So I'm going to cut off y a little bit by doing the following. Are you seeing what's going on? Yeah. So here's my fitting signal, right? So instead of doing this, let me do nx, right? The same time, correct? Y0 fit. Oh, fit. There we go. Looking clean? Yeah. And you're seeing the filter, right? You've seen the delay, right? Filters are going to have delays too. So he didn't make you plot the phase. But once you get into the advanced DSP classes, you're going to see delays are going to be a big problem, okay? Ideally, you want everything to filter out just like that. But because of memory, right, there's delays in your system, you're going to have a natural delay, okay? See how this cosine right here is right there, and this right here is this? What's the phase difference, right? It's off by 3 delays, 1, 2, or about 2, right? Is that cool with everybody? And then let me call this title. Oh, no. Title. What do you call it? Signal 1. Okay, I'll give you guys this pretty plot. There we go, pretty plot. Cosine pi over 10 times n. So is anyone bothered if I do this? Pi over 10 times n. Do frac. There we go. You don't have to do this, but if you want to, you can. Cosine. You can do the interpreter in here. LaTeX. Let's see if that works. Ah, it didn't work. Oh, money signs, money signs. Money sign. There you go. Dollar symbols. You guys like that? Oh. And then, can I do font size 16? You like that? Oh, let me do this. Pi. There you go. Clean. So now you have to do this. Okay, this is what this is going to be your job, your homework. Subplot 3 rows, 1 column, position 1. Cool, right? Now you can do the second part, the third part. Be my guest. Okay, enjoy that answer. But are you understanding what's going on? Are you understanding what's going on with why I'm doing this NY, right? Are you guys understanding why I'm doing Y0 fit? Y0 being this right here, X0 related to this, X1, X2, correct? Making sense? I'm using full convolution. I did a unit step because that's what makes me happy, okay? You can do it like this, or you can do it like this, okay? So now let me see. I don't know if I want to get into this. Let me just check something. There you go. Because I want to get deep into this, but I don't want to like make you guys go crazy. Like, hey, something happened. You can predict any output based on any input in this filter. So if I gave you a faster signal, it's going to be like right here. Oh, just multiply the signal by the magnitude and the phase. This plot will give it to you. Okay, someone's probably complaining, hey, I like filters. Show you this. Does that look like a filter? Yeah, looks cool. Let me do this. Abs H. No. Log 10 abs H. Absolute value. Whoa. Ooh, that looks good. That's a filter. Is that? Did you see this in your courses? This like nice little comb or something like that, right? And then you can see right here. If you go right here, the maximum magnitude, right? Your magnitude response. If you have a super slow signal, I'll multiply it by this and the phase. Okay? And if I move it down, you're going to see, hey, you lose the signal. So there's a point where your output will be 0 if you give it the correct conditions for your input. Okay? I like this. This actually looks really cool. I really like it. Okay? But please change this answer, okay? Wink, wink. Okay? Make sure you guys do that. Exercise 3. Anyone have trouble with this one? It's okay, don't worry. Exercise 3 is asking for... Okay, oh yeah, by the way. I'll give you that. Okay, okay, let me just go over this. Okay. Gaussian noise, right? Use this random function, right? From 1 to 100, right? Or one row, 100 columns. Is that right? What is this number correlating to? Yeah, my input. So make sure this and this like each other, okay? I don't know if you're using n or your size is going to be 100 or 1,000. I don't know which signal you're using, okay? But make sure you put the right number here. You see, assuming x0 has 100 samples, okay? So if x0 has 51 or 55 samples, you make sure you give it this. Want to know the easy way to do it? There is an easy way. Watch this. If I were to do the following. Noise is equal to rand 1 length x nx. Easy? My noise generator. Cool. And then use the filter command. You'll see how cool it is. Okay. So you're going to use the filter command on your clean signal, okay? X0, X1, X2, right? Then you're going to do this, you're going to use the filter again, but with noise, okay? So you're doing the problem 4 times. All right? First time using convolution, second time with the noise, third time with the filter command, and the fourth time filter with the noise. All right? Gaussian noise. High pass filtering. Okay? How do you visualize this filter? Well, you just draw it. I don't want to get to this pretty quickly. Let's see. Let's call it Fourier filter, high pass filter. So omega, right, is going to be from minus pi. Let's copy paste right here. Let me copy this right here. There we go. Save some time. From minus pi or minus 0 or minus pi to pi with this increment. Don't need to worry about this. Don't need to worry about that. There is only one h. So all you're doing is 1 minus e to the minus j omega. 1 minus exponential exp minus j dot times omega, right? And then let me just copy paste this right here. Okay, figure my high pass filter, okay? And then this right here is my, what do you call it? What's he calling it again? Derivative function. Derivative filter. Okay, there we go. Let's run it. Oh, there's a problem. Let me call this one H high pass. Okay. H high pass. Is that cool right there? Not too hard, right? When it's at low frequencies, right? It chucks it down to 0. But let's do a little correct. Log 10, right? Is that cool with everybody? Is that a high pass filter? Okay, let me just show you again. 0. High pass filter? Right? You know what? Let's do something even funnier. Semi-log x. Ooh, yummy. Does that look like a filter? Did you understand what was going on? Right? 20 log. If I were to point right here, right? Here's 1 decade, right? And then here's another decade. Right there. Oh, whoops. 20 times. There we go. Okay. See, I'm learning too. Okay. 20. We're doing power decibel. There we go. That looks good. Y label amplitude in dB. There we go. You guys are gonna have some really nice MATLAB codes. In dB. Ooh, looks good. I'm gonna go right here, 0, right? Right there. Okay, here's my 0 frequency, right? And here's right there. What is that? 20 log, right? 20 log Bodie plots. Cool. All right, but that's not the point of the assignment. Exercise derivatives. Let's copy some things. Let's copy all this right here, okay? Boom. What's going to be my H? How'd I get that? Reading the assignment? Right? Right? Cool? That's your filter. When does it start? At n is equal to 0 to 1. Nothing too bad. Let me get rid of this. Yeah, literally, there's no other way to describe this this function right here. Okay? And then maybe let's start introducing my derivative filter. Okay? The time for it. Then let's do unit steps. Unit steps. And then here is my first signal. x0. Okay? Cool. And we're going to use the same time right here, right? Is that good with everybody? Not too bad? Copy paste. Let's see. Is this assignment a little too tough? Not too hard? Man, I'm just copying and pasting this, huh? Convolution. y0 d, I'm calling it derivative. Is that good with everybody? And then h, I'm going to call this hd for derivative, right? Because we're doing a derivative, right? The change, hd underscore d. Full convolution, nyd is equal to nx, right? The time, nhd, okay? Come on, there we go. nx, nhd. y0 fit, right? I'm going to do underscore d underscore fit. Is that good with everybody? Not too bad. y0 d, length of nx, right? Let's go over here. Figure this. Okay. Boom. Boom. Figure name derivative filter. nx y0 underscore d underscore fit, right? That cool? And then, oh, I forgot my x labels. Please do this for the grader, okay? X label n, right? Y label amplitude. And then, okay, let's not be lazy right here. Copy paste. Not there. Boom, make it pretty. Does that look good? That is your derivative. Everyone understand what's going on? What's the derivative of cosine? Sine, right? Right? No, the derivative of sine is cosine, but the derivative of cosine is minus sine. Right? Wiggle, wiggle. What if I increase the frequency? How do I increase the frequency? I don't know, let's make this 6, right? I'm increasing the frequency, right? Oh, look at that. As we increase the frequency, correct? It gets closer to 1. Let me do 4. You seeing that? And then I'm going to do something funny, so if someone does copy this, fix this. Okay? Cool? Is everyone understanding this assignment? And let me see what else he tells you to do. Adding signals isn't too bad. If you don't do the times, or what do you call it? If the times for this signal and this signal are not the same, you're going to get an error right here. for x at 2, okay? So that's why I'm trying to encourage everyone to try to create like some type of like, system of like, okay, every time I do x, right, I'm going to do nx, right? Okay, practice this, okay? X is going to have a time associated to it, right? Nx, okay? Minus 100 to 100, right? H, right? H is the impulse response, okay? It's going to start generally from 0, okay? From 0 to length of the signal, m or n. I don't know what he's using, okay? It's going to have a time from 0 to, n, okay? I like putting the unit step. It makes me really happy. Here's your signal. Change this. Okay? I'll give you this file. Okay, you guys can have fun with that. Is this making sense with everybody? Any questions? How's the, let's see, okay, so there's that. Let me talk about this. Do the white Gaussian noise, okay? Add it to the signals, xi, I standing for 0, 1, 2, okay? Ooh, okay. I just told you this answer, but let me just verify one last time. Okay. Explain the effects of the filters. Okay? What does the low pass filter do? Passes low frequencies, right? How about this one? Explain the effects of, the high pass filter on the signals. There you go. Sounds cool? And then repeat this problem right here using the filter command. Then repeat, this part right here with noise, okay? Are you seeing what's going on? So you're going to have 4 plots, right? The low pass filter, the subplots with all the signals, the high pass filter, and the signals, okay? The signals for the high pass filter. Okay, not too bad of an assignment, right? Due Friday, right? Thank you all for making it due Friday, because I'm like, if it were due tonight, that'd be a lot, okay? Because I want to make sure you guys have time to digest this, okay? And then let me just check one thing, because now I need to figure that out too. BrendanMorris.com. Dr. Morris. So, okay, you are talking about, you talked about Fourier. You're talking about Fourier series properties, right? What else did you guys learn with Fourier series properties? The additive property, the multiplication properties, all those little stuff like that, right? Not too bad. Convolution recap. So everyone understands, let me say, if this were on the exam, I'm looking at his videos. This is a really nice problem, okay? There is an error in the video. I found it. Let me see. I found it. It was like, I was like looking at it, I was scratching my head. Because I was like, that Stevie taught me a little differently. But let me see. It's not running anymore. Darn it. Let me see if I can give it to you. Where's my, is it right here? Not that one. That's my other assignment. Let me see. Go to Files. Then he gives you the solutions to the homework. There we go. Homework. Was it homework 2 or homework 3? I don't remember. Homework 2? There's a problem I really, really liked. Are you understanding how convolution is working? Right? Because there's a property I need to show everybody, but it's not going to take too much of your time, okay? One of the things I saw from his notes, and it really got me because I was like, wait a second, I want to talk to him about it, is the property where you're doing this, right? It was, let me do this. K is equal to, was it N1, right? And then K is equal to, or K0, N0, right? A of K, correct? Is that cool with everybody? So he did a weird thing where it was like, I don't remember what it was. infinite series, where he did like this. I'm trying to remember it. Like it was like A of something. Gosh, I can't remember the problem. I solved it on my iPad, but let me see. Let me see. It's not showing up here. But yeah, basically what happened was, if you understand what's going on with these, did he prove this equation? Did he prove to you this equation right here? Yes? He showed you how it's going, so he did like this. A of 0 plus A of 1 plus dot 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 A of n, right? Did he show you this? And this is all equal to some summation of n, right? Right? So there's a trick, and basically what was happening, I saw it was like an error. He did like this. Investigate this for me. It was like n, I can't remember, something here. But he forgot a plus sign. It was like A of n plus 1. He forgot this, okay? Don't forget this part, okay? Then 1 minus A or something like that. I think that's how it was. Okay, is this looking a little bit familiar? Yeah, he forgot a plus 1 there. I was like, when I didn't see it, I was like, wait a second, something's wrong, okay? So review, your exam is Tuesday or Thursday? Thursday? All right. So you guys have good enough information. Are there any other final questions for me? I guess we have a review next week. I'll ask Dr. Morris what he wants to do, but else there's no more assignments after this until April. Okay? Sounds cool? Have a good day, everybody.